Ever wondered what makes some materials let electricity flow easily while others put up a fight? That fight is called resistance. Think of it like a narrow pipe trying to carry a lot of water. The narrower the pipe, the harder it is for water to flow. Similarly, the higher the resistance in a wire, the harder it is for electric current to pass through. Every material has its own unique pushback against electricity, and we call this specific resistance or resistivity. It's like a material's electrical fingerprint. Copper, for example, has very low resistivity, which is why it's perfect for making wires. Rubber, on the other hand, has super high resistivity, making it a great insulator to keep us safe. Now, let's talk about circuits. When we connect multiple resistors, how do we find the total resistance if they're lined up one after another? That's a series connection. Here, you just add up all the individual resistances. So, if you have a 2-ohm resistor and a 3-ohm resistor in series, the total is simply 5 ohms. Easy, right? But what if the resistors are connected side by side, giving the current multiple paths to take? That's a parallel connection. Calculating the total resistance here is a bit different. The rule is that the reciprocal of the total resistance equals the sum of the reciprocals of each individual resistance. It's a bit more math, but the cool thing is, the total resistance in a parallel circuit is always less than the smallest individual resistor. Sometimes, you'll see a mix of both series and parallel connections in the same circuit. To solve these, you just break it down, calculate the parallel parts first, then treat them as a single resistor in the series part. So, how do we control resistance in a circuit? We use components like potentiometers and rheostats. A potentiometer is a variable resistor with 3 terminals. You've definitely used one before. It's the volume knob on your stereo. By turning the knob, you change the resistance and control the voltage, which adjusts the sound level. A rheostat is similar, but it's usually used to control current. It typically has 2 terminals and is built to handle more power, often used in applications like controlling motor speed or dimming bright lights. Finally, let's look at a clever device called the Wheatstone Bridge. Imagine a diamond shape made of 4 resistors. A voltage source is connected across 2 opposite corners, and a sensitive meter called a galvanometer is connected across the other 2. The magic happens when the bridge is balanced. This means the ratios of resistance in the 2 arms are equal. At this point, no current flows through the galvanometer. Why is this useful? If 3 of the resistors are known, we can adjust one of them until the bridge is balanced, and then use a simple formula to calculate the exact value of the 4th unknown resistor. It's an incredibly precise way to measure resistance. And that's a quick tour of electrical resistance, from the basic idea to how we calculate, control, and measure it. Hope this helps you understand the amazing world of circuits a little better. Thanks for watching, and don't forget to like and subscribe for more.